So in this video, we're going to talk about how to write chemical formulas of ionic compounds. All right, and so they follow series of rules that we always need to keep in mind when we're writing the formulas for chemical compounds. Okay, so like the first thing that we gotta always remember that all ionic compounds, all right, all of them are always neutral. All right, and so they always have a neutral charge. So when you write the compound itself, it should not have any charges on it whatsoever. Okay. Now, when it comes to trying to figure out the chemical formulas of the ionic compounds, what you need to do is first you need to kind of identify, okay, what are the ions and the charges associated. Okay. Once you could kind of figure out what are the ions and the charges, what you then going to have to figure out is how many of each ion do you need to make a neutral compound. All right. Now, the caveat with this that you need to also keep in mind is that you must use the lowest possible ratio between the ions. Okay, so what I mean by that, let's go ahead and let's do a couple of examples so that way hopefully this will make sense. So let's just say we're talking about sodium and chlorine. Okay, we're going to write the chemical formula of a compound that consists of sodium and chlorine. So the first thing you need to do is look at the periodic table and kind of figure out what are the charges of each of these ions. All right, so we'll come up with a periodic table, and here it is. All right, so here's my periodic table. Now, when it comes to the charges, depending on what type of element, you could easily kind of figure out what's the charge for each of the elements, and we kind of talked about that in the previous video. All right, so let's just get straight to the point. I guess in this case, we see sodium here. Sodium is, apologize for that line. All right, sodium is right here. So sodium is always a +1 charge. All right, and then chloride or chlorine, it's on the halogen, so that's always a -1 charge. All right, and so when we think about the charges, sodium is a +1, chlorine's a -1. All right, and so if you notice, the magnitude of these numbers are exactly the same. So it's a 1-to-1 ratio here. For every +1 sodium, for every 1 sodium, it'll be neutralized by 1 chlorine. And so to show this, all we will simply write is NaCl, 1 sodium and 1 chlorine. Okay. Let's look at another example. Let's say we have calcium and oxygen. Okay, let's look at our periodic table. Let's figure out the charge of each. We notice that calcium has a charge of 2+. Oxygen has a charge of 2-. All right, and so when we rewrite this, we have Ca2-, or 2+, I'm sorry, plus you have oxygen, which is a 2-. If you notice, this is a 1-to-1 ratio. So that simply means that we need 1 calcium for every 1 oxygen. Okay. One more example with this 1-to-1 stuff. All right, let's say we have, for an example, aluminum. Okay, and let's look at phosphorus. All right. So aluminum, as you see here, is a 3+ charge. Phosphorus, which is right here, it's a 3- charge. Okay, so when we write this, aluminum 3+, with phosphorus, which is 3-, and because they're both 3s, one's positive, the other one's negative, it's a 1-to-1 ratio. Okay, now what if it's not? let's look at this example. What if it's not? Well, let's say we have okay, let's start off with let's go back to calcium. I like calcium. Calcium and chlorine. We'll go back to chlorine as well, since they're very familiar to us. So we already said that calcium has a 2+ charge, and then chlorine has a -1 charge. Okay, and so we have to figure out how many of each of these ions do we need in order to make a neutral compound. All right, and as I said, you will need the simplest whole number ratio as possible. All right, so there's several ways that I guess you could kind of think about this. You could do this, and I'm gonna show you the different ways, and whatever works with you, hey, go for it. Okay, and so some people like to draw it out, right? And so, like, for example, you want to draw it out. You say, okay, I have a calcium, that's a 2+. I have a chlorine, that's a -1. How many of each do I need? Well, since this is a 2+, then I would need another chlorine -1. So that way it's a total of -2. So that simply means it's a CaCl2, showing that there's 2 chlorines. Now, another way to kind of figure out what's the chemical formula for this is determining what's the least common multiple of the magnitude of the charges. All right, so what do I mean by that? So let's kind of go back to calcium. Calcium is 2+, and chlorine with this 1 negative, and you typically just write the negative. You look at these numbers between 2 and 1, and you have to figure out what is the least common multiple between 2 and 1. Okay, it's back in the day with like middle school math, right? So the least common multiple between 2 and 1 is 2. Okay, so how many times this 2 goes into this 2? Well, 2 only goes into 2 once. So I'm going to write calcium 1 time. How many times 1 goes into 2? Well, 1 goes into 2 twice. So it's chlorine 2. So that's another way you could do this. Now, the third way I could show you, which is, I'm not going to lie to you, my least favorite way of doing this, because it doesn't always work, but let me tell you the exceptions of when it doesn't work. All right, and so you have Ca plus 2, Cl negative. Now, essentially what you can do, you could take the 2 and cross it over to the chlorine, take the 1 and cross it over to the calcium. All right, and so when you write your answer, it's going to be CaCl2. Okay, now this only works if you cannot simplify the charges into each other anymore. Okay, let's see what I mean by that. Like, so for example, if you have here's a good example. If you have Ca plus 2 and oxygen minus 2, all right, you can't just simply cross the numbers over, because if you do that, then you get a Ca2O2, which is completely incorrect, because that's not the ratio between calcium and oxygen. Because they have the same numbers, all right, it is a 1-to-1 ratio. So the answer to this one, it should just simply been CaO. All right, and that's why I said the crossing over method, to me, it's not necessarily, I kind of don't like it, because what I find with a lot of my students, it's like, oh, crossing over method, and they just cross over everything without even thinking about the charges and its potential ratios to one another. All right, and so if the charges could actually go into one another evenly and the numbers could be simplified, this crossing over method doesn't work. Okay, but the numbers can't go into each other, and it can't go in any more simpler, then it works. So it just depends on the scenario here. Okay, so let's do another one. Now I'm gonna show you each of the 3 different formats I've shown you guys, so that way you choose what you want to use and do what feels good to you. All right, so let's say we have magnesium, and let's go with nitrogen. All right, so when you look at the periodic table, you notice that it is a Mg. Magnesium is a 2+, right? Nitrogen, its charge is a 3-. Okay, so that's what we see on the periodic table. All right, so let's go with the drawing method, right? So you have Mg2 plus, and you're trying to figure out how many of each do you need. All right. And so obviously, if we just merge those two together, it's not going to be neutral. It's not going to work. All right. So we know we need more of something. Well, if let's say, if I add another Mg2 plus, then I see, okay, well, altogether, really I have a +4 charge. Okay, let's add another nitrogen. Well, if I do this here, then altogether I have a -6 charge. Okay. Then what that possibly mean? I think some of you guys could think this through. It's like, well, obviously you might need another magnesium, okay? And if we get a third magnesium, then we'll have a total positive charge of a +6, okay? And so you see that there are 3 of these, there are 2 of these, and then so when I write the chemical formula, it'll be Mg3 to represent each of these I have, and N2. So this is your Mg2. This is what magnesium, nitrogen, when they bond together, this is what they make. Okay. All right. Let's look at the other way of doing this. All right. So once again, you have Mg2 plus and 3 negative. You will have to figure out what's the least common multiple between 2 and 3. So a little bit thinking, least common multiple 2 and 3, meaning what number or the smallest number that both 2 and 3 could go into. All right, or equally divisible to, right? And that number would be 6. Okay, there's no number lower than 6 that's a non-decimal number or integer, whatever, that both 2 and 3 could evenly go into. All right, and so how many times 2 goes into 6? Well, it's 3 times, right? So we write Mg3. How many times 3 goes into 6? Twice. So N2. By far, this is my favorite method. I'm not, try not to be biased, but it is. All right, so that's one way you're looking at it. All right, and then the other way is your crossing over method. So Mg2 plus, you have nitrogen 3 minus. So I'll take these numbers and I'll cross them over. All right, the only thing you just want to make sure first is, hey, can these numbers go into each other? No, they can't. Not evenly. All right, not without a decimal number. So that's fine. So when we write the answers, you'll have Mg, you cross down the 3, and N, you cross down the 2 from the magnesium. And so this is your answer as well. All right, so let's look at another example. All right, so let's use a transition metal this time around. So remember, your transition metal, when they become ions, you must always include the Roman numerals. All right, the Roman numerals represents the ion. So let's just say we have a copper 2 ion, okay, and it's going to bond with, let's go with a sulfide, okay. So copper 2 ion, that's a Cu2 plus. A sulfide is S2 negative. All right, and so let's look at the charges. Let's go with the drawing method first. All right, so you have Cu2 plus, sulfur 2 negative, and you're looking at this. It's like, oh, this is 2 to 2 to 1 to 1 ratio. So simply is Cus. Okay. Let's look at it from a least common multiple perspective. All right, so from least common multiple, you have Cu2 plus, sulfur 2 negative. All right, you look at the numbers, it's like, okay, what's the least common multiple between 2 and 2? Well, it's 2. All right, how many times 2 goes into 2? Once. How many times this 2 goes into 2? Once. So then Cus, okay? All right, and now this is the point when I say this crossing over method doesn't necessarily work because it's 2 to 2. So if you cross it over, then you go write Cu2S2, which is completely incorrect. Remember, your chemical formula must have the lowest possible ratios between one and the next, and we know that the ratio is a 1-to-1 ratio. All right, so that crossing over part will not really work with a scenario like this. Okay. Now, let's go a little bit complicated. So let's say we include a polyatomic, okay? So let's say that we have, let's go with aluminum, okay? And let's use the polyatomic nitrate, okay? So you'll look up both of the aluminum ion, so this is the ion, and nitrate itself. And so we see the aluminum ion is a 3+. Nitrate It's NO3 with a -1 charge. All right, so now we need to figure out what combination of the both we need in order to make a neutral compound, right? And so drawing method, so we have aluminum 3 plus, we have nitrate 3 negative, and so you notice it's like, well, if nitrate's only a -1 charge, aluminum is there's a +3, then we're going to need 3 nitrates in order to completely cancel out the the positive 3 charge of the aluminum ion. Okay, and so how do we show this? How do we write this? Well, we'll write aluminum once. If you notice, there are 3 nitrates, and to show that there are 3 nitrates, or if you have multiples of any polyatomic, you'll put the polyatomic in parentheses, the NO3, and then you write the subscript of how many you have outside the parentheses. This is important, okay? And so why this is important, I'm just going to try to illustrate this. If you change the subscript of a polyatomic, you're changing the polyatomic, okay? And so to show that there's 3 of them, if you write this will be incorrect, because what you're showing is there's only 1 nitrogen and there's 3 oxygens. But you're trying to show there's 3 nitrates, okay? Also, don't do this. Adding another 3 at the end, that means there's, in this case, 1 nitrogen and 33 oxygens. That's not what you're trying to portray here, okay? And so just always kind of be careful about that when you're writing the chemical formulas. All right, anyways, let's look at the other method, the least common multiple method, right? My favorite method. All right, so if you notice, this is a +3, this is a -1. What's the least common multiple between 3 and 1? Well, it's 3. How many times aluminum goes into 3? How many times a 3 plus goes into 3? Well, only 1 time. How many times 1 goes into 3? Well, it goes in there 3 times. So in parentheses, I write nitrate, and then I'll show, not as a superscript, I'm tripping, as a subscript, it's a 3, okay? And then the crossing over method works in this case. So you have Al3 plus, nitrate negative. So take these numbers, or really just a number, all right, and you switch it over. And so you have Al1 in parentheses, NO3, 3. All right, so just always remember this as you're writing chemical formulas of ionic compounds. All right, if you always notice that it follows a very specific order, right? Your ionic, for your cations, are always written first. The positively charged ion is always written first in the chemical formula, and then you write the anion afterwards. Okay, so it always goes in that order. It's always the metal, then the non-metal. It's always the cation, then the anion. Okay. If you noticed also that the chemical formulas that I write at the end, the ionic compounds, never includes charges, because the ionic compound has a charge of 0. It's completely neutral, so you never will add a charge with your chemical formula. Okay, and then last but not least, which this part is really important, is that your polyatomics, all right, if there's more than one of them, they need to be placed into parentheses. Okay, so that's just kind of the big ideas for this. All right, see you next time.